I'll just ask her.
Okay, today. So,
Quit bullying your teammates.
all right.
You bully? Is that encouraging your team?
Hey. Okay, today, what we're going to be doing, we're going to be talking about the different ways to graph polynomials today. So our major goal today is to go onto this graph and actually graph multiple different types of polynomials today. Obviously, we know the basics. On a graph, remember origin's the middle. We have the x-axis, we have y-axis, we have the quadrants. The big thing I'm going to be telling you today is to look at certain parts. So if you don't know where the quadrants are, this is quadrant number 1, quadrant 2, quadrant 3, and 4. They go counterclockwise today. You need to know that. Other things, x-intercepts. What does an x-intercept mean? Yeah, so if your line crosses like this, yeah, there's 2 x-intercepts on that particular graph. If we have a y-intercept, it hits the y-axis somewhere. That's what we're looking for. So those are terms I'm going to use today because obviously we've been talking about quadratics, right? I'm going to graph quadratics today. I'll kind of show you that. But I want to make sure that you understand the parts. So when I ask for intercepts and all that good stuff, you kind of know what you're doing. Okay? All right. So let's go through the first part here. Let's walk through the different polynomials and the different checks that we're gonna have to do today. I am gonna give you a little bit of time today to work on your homework. That was the assignment I gave you yesterday. I forgot to put it on the board, but I'm gonna put it up there today. All right. Hey, talk later.
No, Mr. Ward, it's about your camera.
Talk later. It's on your camera. Okay.
She has your camera.
I know.
It's right there. It's right there.
Hey.
I told you.
Excellent. Thanks. Good. All
Hey,
right.
you should probably start that.
Yeah,
So you start now.
Let's start that.
So I
Go
already got
set
the
up
phone
the
going.
big camera.
No.
If there's different
Okay.
angles.
We need the big camera.
Wait,
Hey.
why aren't you asking
Hey, if you guys keep talking, I'm not going to give you time to work on your homework today. I'll do notes the whole time. So, no. Talk. Ask later.
It's important.
Okay. All right. Here's the section. We're on section 2.3 today, which is graphing polynomials. So, graphing polynomials today. All right. Checklist that we have to make sure of. Number 1, we have to talk about leading coefficients. That's checklist number 1. Okay, when you graph, leading coefficient test. Okay, this will tell us something. There's 2 parts that go with the leading coefficient test. It basically goes with what they shouldn't use green. What they talk about, what they refer to as end behavior. Behavior. There we go. Spell right. All right. So we're talking about end behavior, and that goes with the leading coefficient test. Second thing that I always talk about is the number of x-intercepts or y-intercepts. Now, some people consider that all in one. There's a difference here. X-intercepts, obviously, it's not just what axis you're hitting, but for x-intercepts, there's an actual test that we do for x-intercepts, and it's called a multiplicity test. That test can really mess with people, unless you know exactly what you're doing there. All right, and then the last test that we do, other than multiplicity test or Y-intercepts, the last test that we actually check for is a turning point test. Turning point test. Okay, so these are the major things that I look at when I'm going to graph a polynomial. It's not just a quadratic, any type of polynomial. We're going to start with quadratics so you can see it. So you get kind of familiar with how to graph, because this will help you with your homework today, knowing the different parts. But how do we do it with polynomials when we don't know the sizes? Or we don't know how to do all the different types of math to it? So that's what we're going to look at today, and I'm going to pull some examples from textbooks. We are going to do a book check today. That'll be the second half today. It'll be right when I give you time to work on your homework, I'll check your book numbers. So if you don't have your book, you're going to have to go grab it, because I am going to check your book. But let's jump right in. Let's do a quadratic first, because I do want to kind of review what we did yesterday in the homework. Now, quadratic, just so you know, like the actual function itself, I'm just going to put it in standard form right away. This is a quadratic. That's quadratic. That's in standard form so we can graph it. Okay. Now, how this works, how you know which way it's going to go. On this particular problem, this number in here is the x-coordinate. This number over here is the y-coordinate. And we always pick the opposite of those numbers. That's what we call, this is the vertex for that particular quadratic. Now, what makes the quadratic has power 2? Okay, so that's the idea. So for the vertex, the opposite number with the x is -1. The opposite number with the y is a 5. That's the actual problem that I'm doing here. So -1, 5. Okay, and again, for quadratic, you know, we know the shortcuts. We know where the vertex goes. We know how to find x-intercepts, y-intercepts. X-intercepts for this particular problem is when you plug in a 0 for y, and you actually like solve that thing out. So, in fact, I'm going to put those over here. So if I'm finding x-intercepts for your particular problems, there's 2 ways to do it. For x-intercepts, you could plug in 0 for the y. Like that. Oh, okay. So I could plug in a 0 for y, and then just solve that thing out if it's quadratic. So this would be -5 equals 2x plus 1. And how I would actually solve this very, very easily, you would divide the 2 over. So this would be -2.5, because I want to get the parenthesis by itself. I would take the square root to the other side. So this would be the square root of -2.5. And say it again. What do we say? What were some of the mumbles?
No, I just said.
Oh, equals x plus 1, and then we subtract 1 over, right? All right, Ray, watch the video later tonight.
Plus or minus.
Ray,
Well,
you
no,
don't
plus
have
or
to
minus.
concentrate because it's on his phone, not the camera.
Okay, all right. So I subtracted the 1 over. Now, what you heard earlier when we took the power of the other side, bless you, we took plus or minus the square root. This number right here. What's the problem with this?
It's imaginary.
Negative. You need to bring
It's
up
imaginary. It's 9. That means this problem doesn't have an x-intercept. Now, some people look at it and go, okay, fine, you know, you solved. That's one way to solve. The other way you could do it, if you actually wrote this problem out and you actually like foiled it together and looked at what the original problem was before it was in what we call standard form, you could have done the quadratic formula. We could have tried to factor it apart. Just to show you what that is, we already know the vertex. I'm going to get rid of this. If I FOIL this all out and I put it back to its original problem, like the quadratic, what most people think of is like a trinomial. This is 2, and I'm going to write the 2 parentheses out, x plus 1, x plus 1. FOIL it all out, that's x squared plus 2x plus 1. Distribute the 2 through that parenthesis, and I get 2x squared plus 4x, and that would be a 2, and if I add the 5 to it, that would be a plus 7. This is what most people think of as a quadratic, okay? And because that's like a normal polynomial, right? Well, if you could factor this thing apart, you could figure out the x-intercepts. The problem is that problem can't factor apart. That doesn't automatically mean that it doesn't have x-intercepts. It just means it wasn't factorable. There might be decimals, okay? Because there's no way to break the 7 and the 2 to make the 4 in the middle when you're trying to factor it apart. But you could do quadratic formula, because the quadratic formula gives you x-intercepts. That's this song and dance number thing that you did. I think it'd be plus or minus square root. B squared minus 4 times a times c, all over 2a. And remember, the a, b, and c for that formula, this is a, it's just the 2. The b is the 4. The c is the 7, not the x's on them. Just the numbers. And that's the numbers I plug in down here, and I can see, and yeah, it would turn out to be a negative radical, which is imaginary. Because again, it's never going to hit the x-axis. So, you know, leading coefficient test, we know it's a radical, we know it's a parabola, so the bowl's going either up or down, right? So that's something we're going to talk about today. We know x-intercepts, we've already done stuff like that before, you know, where you factored apart, or you do quadratic formula to figure out x-intercepts. Y-intercept, though, is a lot different, right? A y-intercept, if I go to this original problem here, and I want to figure out, in fact, I'm going to put it over here. If I want to do a y-intercept to that problem, And you know, when I simplified this problem, it was 2x squared plus 4x plus 7. If I want to do a y-intercept here, the y-intercept is where you make all the x's zeros. Yeah, it's 7. It's just the quickest way to do that is you get rid of anything that has x's on it, and the answer is 7. So I know I'm going to hit 7 on the y-axis. And then, since it's a quadratic, it's symmetrical. It's doing that. Tail's going up. And how I know the tail's going up? The leading number tells me that that's the test we're going to talk about today. Like, there's little things we need to learn. Okay, we'll talk about turning point tests and all that good stuff. Okay, now obviously these are things we've done previously. The new stuff makes it a lot easier to look at. That's what I want to walk through today. Okay, so you guys ready to go?
I hope so.
Okay, so we're going to walk through each of these tests one at a time on random problems I'm going to pick from the book, and you can see how do they all apply, how do we know what the graph is roughly going to look like. Okay? Okay, so we're going to just kind of pick some random problems out of the book, just so we can see it, and we'll try to graph them. All right, so let me pull a problem from the book here. Okay. All right. Okay.
See, I was in the process of writing.
Maybe we'll start with like one of these. Pick like one of these for 40, 41, 44. Pick one of those because they're easily factorable. So we can kind of do some checks. Okay, hey, so, okay, we're going to walk through these problems now, and we're going to try to do the different tests on one particular problem. So pick one at random. What do you got?
F of x equals
Okay. Okay.
x to the fourth minus x squared.
Okay, all right. Okay, so this is my polynomial, right? All right. So it's power 4, so it's a quartic function, not quadratic. So it's got a power 4. So what we're gonna do is we're gonna walk through these checklists and the little rules that we have to know roughly how to draw this thing. You know, a rough approximation to it. Okay. All right. So how this works? We're going to do the first one first, the leading coefficient test. So the first step, let's look at the leading number out front. Is it a positive or negative number out of the biggest term?
Positive.
Positive. Okay, so if it's positive, this figure, the graph, will go a normal. It'll be a normal drawing, a normal sketch. What I mean by a normal draw is normal sketch. If it was negative, the picture flips over and goes the opposite direction. So since it's positive, this graph will be normal, quote unquote. Okay? Now, the power on the leading coefficient, the biggest power, the highest degree, the degree of this item will tell us the tails, the end behavior. Okay, so yeah. So if the power is even, right? So it's an even power. So in this case, if it's even, the tails go the same way. So tails go the same direction if you have an even power. If you have an odd power, the tails go opposite directions on your final graph. So since mine is a 4, the tail's going either both up or both down, the final ends. And the plus means they're going basically towards the positive. That's how I think of it. That's a normal graph. So on the outsides, this is what we're looking at. The tails are going up somewhere. I don't know where right now, but I know they're going up. Does that make sense?
Yeah.
Okay, so that's kind of the rough test. That's called the leading coefficient test, and that's also the end behavior test at once, because you use the highest degree item to tell me where that thing is going. Okay, does that make sense, the two parts? We'll do maybe an odd problem next. Okay, now, the next thing, we have to figure out x-intercepts. This requires that you can factor this problem apart. And I will always try to give you a problem that is factorable, so you can figure it out. And then we're going to talk about what they call the multiplicity test, so we can see how this problem is going to work. Okay? All right, questions, comments about the first test, though?
No.
Okay,
No.
so let me get rid of the rules here. Does everyone have it written?
Yes.
Yes.
Fine. We're good? Is everyone good? Tori, you still right? Teak, you good? Okay, all right, just making sure. Nicole, you good? All right. So now we're done with that. So let me get rid of all the marks here. So now we're gonna go on to the next test, the X-intercepts. This requires that you can either factor it apart, or maybe it's already factored apart and you can read off what those values are. So this problem is the difference of squares. It's perfect squares. So this can go to 2 parentheses. It'll be plus minus. It'll be x squared, because of that. And then this breaks up to x and x. And I know that we can pull up common factors in each of those. In fact, we could have even done that first. Maybe if you, because I know this is one way to factor it. If you saw it, maybe you want to pull out an x squared first, or it's like this, where you pull out the x squared. It'll still work out to be the same answer I'm about to show you here in a minute, because this is still a difference of squares. So now here, what do these have in common? X, so I'm going to pull that out, right? X plus 1. And then I'm going to pull an x from here, x minus 1, right? And then I can rearrange these so the x's will go to the front. There's going to be 2 of them. And then I have x plus 1, x minus 1. It really doesn't matter the order that you actually factored apart. There's 5 rules for factoring. There's common factors, trinomial, difference of squares, cube, and grouping method. So on this particular problem, we're definitely doing difference of squares at some point, and common factor. So this is my problem. Now, on this part right here, these 3, because since there is 3 objects here, there's 1, 2, and 3. They have 3 x-intercepts. So on this particular problem, what makes this one 0? 0. Okay. What makes this one 0?
-1.
-1.
+1.
And +1. Okay. Those are my 3 x-intercepts. In fact, I'm going to put a dot on each of those right now. So it's 0, 1, and -1. I'm going to put dots. Okay, we good so far?
Yep.
All right, now, so we found the 3 x-intercepts. Now, the next test we have to do is called the multiplicity test.
Oh boy.
The multiplicity test is when you finally get down to your x-intercepts, however many there are, and you factor it all the way out. You have to now look at the powers on them. Okay, so on the first one, this had a power of 2 on that parenthesis, because it was x to the power of 2, right? If the power is even, so it has an even power, even degree on it, okay? That means it will bounce. Your graph will literally bounce off of that x-intercept. What do I mean by bounce? That when it hits 0, it's going to bounce like this. It's literally going to touch it and turn around. Now, I don't know which direction we're coming from yet. We'll kind of see that here in a minute. Okay? But whatever, so if it's an even power, it will bounce off of that particular x-intercept. If it's an odd power, like on this parenthesis right here, what's the power on this parenthesis?
That is a 1.
1 and 1. Since these are odd powers,
Oh boy.
it will pass through them.
Forever.
Incredible.
It will pass through. It'll pass through. So if it's an odd power on the parenthesis itself, like you don't have multiple parentheses, it will pass through. So if I'm actually putting this together right now, I can start to see where my graph is going. So it's starting in the upper left corner. It's kind of coming down. It will pass through the 1 and -1 because that's my multiplicity said. My multiplicity test has said to pass through, and I'm going to bounce off the even number. Okay. Now I know there's a couple tests we have to do next or do last here, but I'm starting to get a feel for how this thing is looking. It's starting to look something like this. So it's passing through. It's bouncing off of the 0, and then it's passing through again, and it's doing something like this.
It's a big double.
Okay? Now, questions, comments about what we have so far? Okay. Next, the next step, we have to figure out y-intercept. Well, we already know my y-intercept, but I want to show you how you can find it on yours. So, when you have your problem, this is the f of x, x to the 4th minus x squared. The trick is, you just replace all the x's with zeros, like we did earlier. And so this will turn out to be 0. So we are going to hit the origin for the y-intercept. So it's pretty easy how you start that. Factoring it apart can give me the x-intercepts. but y-intercept you just plug zeros in for all the x's. It's pretty straightforward. Okay, so that's this rule here is just basically a substitution rule. So it's substitution. Okay, now the last rule. There's a couple different things I have to stress on this last one. Okay, the last rule, the turning point test. We're gonna figure out how many times this thing will turn, and at the same time, the last thing we have to check for is it even symmetric.
Yes.
So that's what we're going to check for. We're going to check for symmetry. And that's a test we've actually done before and back in chapter 1. It's something that, believe it or not, we've actually done this before. So, alright, so turning point test. So when we go back to my original problem, is everyone still following with me? Have we done everything so far?
Yes.
Okay,
Yes.
so,
What is it?
It's called the heater, it has water in there.
okay,
It's making
alright.
noise.
So,
Water main.
hey, so, for this particular problem, we're going to do the turning point test first. Okay, what you do is you take your highest degree term, in this case it's a 4, and you subtract 1 off of it. It's always 1. You always take off the, a 1 off of whatever the highest degree term is. And this will be potentially how many turning points we're going to have. So what do you mean by turning points? So the graph will literally go from like decreasing to increasing, or if it's increasing, it'll turn to decreasing. It actually like turns direction. So in my particular problem, it has potential, it doesn't have to, but it has potential to turn 3 different times. So we're going down, so we're decreasing. It turns, that's once,
2,
twice,
3.
3 times. So it did turn 3 times. So we might have the graph somewhat correct.
I have a question.
Okay, question.
Why isn't it required to turn 3 times?
It's not required, depending on like how many x-intercepts it would have, y-intercepts, because you know maybe there's a repeating x-intercept, like where it's like a double root. Well, it may not do something there. It may not have to turn twice. So it just depends on how you factor it apart.
You want to do that again?
Hmm?
How do you get the 4 and the 1?
4 is the highest degree, and then you always take 1 off the highest degree. It's always just subtract 1.
Oh.
That's the turning point test. Now with this, we do have to figure out if this thing is symmetrical. So, because right now, it looks like my picture's like a perfect W kind of shape, but I need to see, is that actually true, or maybe I'm drawing this wrong? Maybe it's like one of these tails is supposed to be longer than the other. So how you check for symmetry? Okay, the symmetry test, here it is. You plug in a negative x into your function. It's kind of like the y-intercept thing that we did earlier. You plug in 0, but we're going to plug in a negative x. So this will be negative x to the 4th power, and a negative x to the 2nd power, or squared. So when I do this, the negative sign will literally cancel out because the power 4 goes in, and it will cancel out the negative. Odd powers will keep the negative. And then right here, the power 2 will go on the inside. It will cancel out the negative, like that. And so we ended up back to where we started, like exactly where we started, because the even powers cancel out the negative sign that I just plugged in. And so this is an even symmetric graph. So what that means, if it's even symmetric, because we turned right back into the original function we started with, that means this graph is symmetrical, and it's going to be symmetrical over the y-axis. So the things this direction and this direction look identical to each other. So it is symmetric. So this is a yes, it's even symmetric. So my W is actually drawn correctly. Now, the problem is, I don't know where these points are. Like, how low did the actual dip go? That's something we do in Calc 1. It's called an inflection point. How you actually find that, you actually do the differential quotient that we just did in our first chapter test, and you actually figure out where those things are zeros. So we'll talk about that later. But for right now, we know that it's going to be symmetric. We know it's going to be turning a couple times, and this is roughly what the graph looks like. Now, I'm going to graph this on Grapher, just so you can see this. I'm going to type it into Google so you can see what this graph looks like. But doing every test for this problem that I started with, it gives me a rough idea where this thing's going. Okay, so I'm going to pull this up just so you can see this.
Yes.
Mr. Ward?
What?
Is number 1, is it prime or composite?
1, it's neither. So we don't.
How is it on prime?
Prime, the definition of prime, you break it up to 2 factors, 1 and the number itself. when you break up the number 1, it only has one factor.
Okay, is 0 prime?
0?
Or no, I mean 0, is it even or odd? That's what I'm
I think they don't consider 0 to be any of them because 0, 0 you don't really break up 0, 0 is 0 itself. If you're going to consider it prime versus composite, I could definitely see it as composite because you have an infinite number of factors that can go into it. But I wouldn't necessarily do that.
That is incredible. That was deep.
I actually did not know that.
All right. So I'm going to graph. So Google. All right. So my function that we just typed in, f of x equals x to the 4th power minus x squared. And I'm going to drag this over here so you guys can see this.
Damn.
Okay, so I'm going to graph that. So it is a W. W shape. All right. So, oh,
Looks like it's a -1 and
So-
-0.25.
so yeah. So these inflection points, like where it actually bottomed out, like these are something we can do later. That's the differential quotient. How you'd actually find that when you do the differential quotient to the original problem, where you take it and you go to the f of x plus h minus the f of x over h, you would actually figure out where those things would hit 0, because the slope at these locations, these lowest points, the slope would actually be 0. It levels out. So you'd actually factor that apart. That's something you do in Calc 1, is to figure that out. Okay, that's something like I'll leave for you guys next year because that's a lot of steps. Like these first 4 lines are really quick. Like I'm trying to explain it to you, so it seems a lot slower than it is. But I can go through problems pretty quickly if I just follow my rules. That I do end behavior, knowing where the tails go. I figure out x and y-intercepts to figure out a couple points in the middle, and then figure out, is the thing symmetric? Is it going to turn a couple times? Where is it going? And I can put it all together to see roughly what my graphs look like. Like before, seeing that problem, I had no idea what I was going to see. But going through these rules, it gives me an idea without having your graphing calculator. Like I do a pretty accurate picture of that thing without a calculator. And we can do it for any type of graph. The only problem is with doing this type of like graphing, if you can't factor it,
It's already over.
yeah, you don't have anything to go off of, right? Because you don't know where your x-intercepts are, you don't know the inflection points. It's really difficult if you can't factor. So I'm going to always try to give you problems right now anyway that you can. I will show you later in this chapter, like when's a problem that you can't factor it apart. I can show you tips and tricks for it, that you know where to go, okay? All right, today I'm going to stop there today. I'm going to give you some time where you can actually work in your homework. So you get about 10 to 12 minutes here. I'm going to do a book check right in the beginning. So have your book out. If you don't have it, go get it right now. But I'm going to call I want to know your book number and all that good stuff, okay?
Look at me back. This book.